To integrate this, it looks like we're going to need to use substitution. And the question is suggesting that we substitute using u equals x squared plus 3. So this is our u. So let's start, as usual, by differentiating u. So we find du by dx, and then finding dx as du divided by 2x. And the idea would be then to rewrite our integration with this instead of dx. So we have 2 times x cubed times e, and instead of this I'm going to write u, and instead of dx I'm going to write du over 2x. Now, it doesn't look like I can cancel that with that, but I can probably cancel one of those x's, and I'll still end up with an x squared here. And as long as I can write that in terms of u, I should be okay. So that becomes x squared. So let's rewrite that as x squared. And that x disappears. And that 2 cancels with that 2. So now my only problem is getting rid of this x squared. So if I can find what x squared is by rearranging this equation here, then we should be able to arrive at something a little bit more acceptable. So let me rewrite x squared here. So x squared is u minus 3, and I can put that in there. So now my integration looks like this. The integral of u minus 3 times e to the power u du. And if we expand the brackets, we have an integral that looks like this. And that's okay, because I guess that's easy to integrate. But this, less so, but we can use integration by parts. Let me just remind you, for integration by parts, the formula typically given to you in the exam is the integration of u dv equals uv minus the integral of v du. So I'm going to use that to integrate that. So let's start with choosing u and dv. So I'm going to choose u and dv. I'm going to differentiate u and integrate dv. So it makes sense that I choose my u. Maybe bad choice. I call this maybe w, so we don't get confused. All right, so I'll change the formula here as well. I'll replace every u with w. Okay, so my w is going to be u, and then when I differentiate it, I get 1. And dv will be my exponential, e to the u, and when I integrate it, remember this is integration, I get e to the u, and then if I apply the formula, I have wv minus integration of v dw. So it's this times this minus the integral of these two. So if I just write out what I've got, integration of u e to the power u, and I'll just keep that in this yellow circle to show that this isn't the whole integration, that's simply the bit that we're interested in, the integration by parts. So that's equal to u times e to the power u, that's the product of these two, this and this, minus the integration of the product of these two. So minus the integral of e to the power u times 1 du. Now this is the easiest integral in the world. It's simply e to the power u. So that gives me u e to the u minus e to the u plus constant. So if I go back to my original question, we had this as our answer. So let's just go back. This is where we're up to, and we can say that the bit here, this is the result of integration by parts. Okay, so this is my integration by parts. And this bit here, this is simply, when you integrate it, you simply get minus 3 e to the power u. So the final answer is this plus this. So I'll just write it out. U e to the power u minus e to the power u minus 3 e to the power u plus c. And I guess I can collect like terms because these add up. So you get minus 4 e to the u. So it's u e to the u minus 4 e to the power u plus c. And if you wanted to, you could take e to the power u as a common factor. U minus 4 plus c, and that would be your final answer. Okay, so we used integration by parts and substitution. So it's a double question. It involved substitution and integration by parts.